The last section on combining organic fragments as Lego bricks to build lots of molecules was so important that I thought I'd just revise some of the key principles. So if we take a methyl group, a methyl radical, and we combine it with another 1 electron donor, that's cool, that's good. But if we take one methyl group and one 2 electron donor, that doesn't work. Or if we take one methyl group and one 3 electron donor, that doesn't work either. Let's consider binding our methyl group to various things. The products are always going to have methyl in them. So it's good to draw out what you already know in organic chemistry when trying to arrive at the answer. So let's draw some methyl groups. And then first of all, try to combine our methyl group with hydrogen. That works because hydrogen is 1 electron donor. That's cool. If we try to combine our methyl group with nitrogen, 1-to-1 ratio, that's not cool because the nitrogen only has 5 electrons. By sharing 1 electron with our methyl group, forming a single bond, it has 6. It's not happy. How about combining our methyl group with oxygen? Not cool either, because oxygen has 6 electrons. By sharing 1 electron with our methyl group in a single bond, it has 7. It's not happy either. What about combining our methyl group to sulfur? Sulfur is like oxygen. It has 6 electrons in the outer shell. If it shares 1 with a methyl group, it will have 7. But then it's still not happy. It would have to bind to something else to be content. Finally, though, if we take our methyl group and we bind it with chlorine, for instance, well, chlorine has 7 electrons. It only needs to share 1 to get 8. And it's quite happy to do that. And it gives you chloromethane. Let's revise also for a CH2 group. That's called a methylene in organic chemistry, methylene. So if we take our methylene and we combine it with oxygen, that's good because oxygen has 6 electrons. It needs to share 2. Our methylene has 6 electrons too. It needs to share 2. And when we combine them, we get formaldehyde, methanal. 8 electrons on carbon, 8 electrons on oxygen. If we take only 1 hydrogen and combine it with methylene, well, the hydrogen is content about that because it has 2 electrons in the outer shell, but the methylene group becomes a methyl radical. It's reactive. It only has 7 electrons. However, if we take 2 hydrogens and combine them with a methylene, well, then we complete the stable octet. We get methane, and that's cool. If we take our methylene group and combine it with nitrogen and nothing else, well, the nitrogen only has 5. If we form 2 bonds to the methylene, which is all we can because there's 4 electrons on the methylene already, then the methylene has 8 electrons around it, but the nitrogen only has 7. So we draw it as N dot. If we take 1 chlorine atom, or chlorine radical you could say, and combine it with the methylene, well, that fills up this stable octet of chlorine, but it leaves the methylene group 1 short. So that would be a chloromethyl radical again. You need 2 chlorine atoms to make dichloromethane and a stable octet around the carbon. I hope you also remember from the Lego bricks video that we can have 4 things around carbon. Like in methane, it has 4 hydrogens, and like in ethane, which has 3 hydrogens and a carbon, a methyl group, around each carbon. But we can also have 3 things around carbon. And the typical example for that would be ethene, which has 2 hydrogens and 1 CH2 group on each carbon. And also we can have 2 things on carbon, 1 hydrogen and 1 CH group, for instance, in ethine. Students learn organic chemistry by remembering some key facts, learning pivotal concepts, then applying the concepts in problems until the concepts are mastered. To help with that, I'm preparing an ebook on hybridization and bonding to be published on iBooks for the Mac and Amazon Kindle. The 4 workbooks, Sophomore Organic Chemistry by Inquisition, are available from Amazon and from the byinquisition.org website, where the answers can also be found. Thanks for listening. Bye.